Okay, so what we've been looking at for the last couple of weeks have been right triangles. Triangles that have a right angle in it. This triangle does not have a right angle in it. It is what we call an oblique triangle. Looking at this, finding angle B, of course, is simple. What do we do?
Subtract 52 and 71 from 180.
Yeah, which leaves us with what, 57 degrees? So 180 minus the 52 and the 71 leaves us with 57. Sides A and B, however, are not so simple to find. We cannot simply apply our standard right triangle trig to these because it's not right triangles. But what we can apply is something called the law of sines. Law of sines states that in any triangle, we've seen that the longest side is always opposite the largest angle, and the shortest side is always opposite the shortest angle, right? But it's not a direct relationship. You don't double the size of the angle and then double the length of the opposite side. The relationship is between that length of the side and the sine of the opposite angle. So inside any given triangle, the length of a side divided by the sine of its opposite angle will be a constant. So the length of side A divided by the sine of angle A will be the same as the length of side B divided by the sine of angle B, which will be the same as the length of side C divided by the sine of angle C. So what that means for this triangle is, do we have a side and its opposite angle? Well, we only have one side, that's the 28 inches. Do we have its opposite angle? Yes, we do. What would be its opposite angle? The 52 is the one angle that doesn't touch the 28, right? So we can set this up as 52 over the sine of 28 degrees has to equal, which side do we want to find first, A or B? Really doesn't matter. We know that's 57 degrees. Let's do A over the sine of, what's its opposite side? 71 degrees. So now all we're going to do is cross multiply and divide, and we will have the length of side A. So 52 times the sine of 71 degrees, make sure you close your parentheses if your calculator does parentheses on those, divided by the sine of 28 degrees. Gives us that A is 104.73. That go right? Yeah, apparently. Why did I put 28 in there? How about I try this again and put the right numbers in? 28 is the length of the side. 52 is the angle. Does that look better? Okay. So it's related to the sine. The biggest angle is opposite the biggest side, but it's not a direct relationship. It's related to the sine of the angle. So let's try this again now that I got it set up right. It's 28 times the sine of 71 divided by the sine of 52. 28 times sine of 71, close parentheses, divided by sine of 52. So 33.596, so 33.60. Because that's the one that seems to work. Years ago, they pounded through it. And they found, there's a long derivation of why it's the sine, but I don't want to take the time to go into that. But what it was years ago they sat down, they worked it out. There is actually a proof as to why it is the sine, but it is always going to be the sine. That's why it's called the law of sines. Is the side within any given triangle, the length of a side divided by the sine of its opposite angle will be the same no matter which side we choose. Not for the law of sines, no. There will be a law of cosines that comes up. That'll be for a little bit different situation. So we found side A to be 33.60 inches. Now I'm going to stop here. Does that make sense? Does 33 make sense? Well, yeah. 28 was across from 52. The 71 degree angle should have a larger side across from it. So 33.6 makes sense. If that'd come out to be smaller, it wouldn't make any sense, would it? But here, that's okay. Now, before we figure out B, where would we expect B to be in there? Smaller, the smallest one, the largest one, or in between them? How do we know it's in between? Yeah, 57 is in between 52 and 71. So this has to be the side that's the middle length side. So we're going to do our 28 inches over the sine of 52 degrees again, equals the length of side B over the sine of 57 degrees. And we shall cross multiply and divide. So 28 times sine of 57 divided by sine of 52. 29.80 degrees. Does that make sense? Yep, it's between the two of them. That makes sense. Now we're going to do more examples of this, don't worry. We've got a couple hours to burn today. But one thing I want to point out here, what we were given, what we knew. Two angles and one side. When we know two angles and one side, we can always use law of sines. Why can we always use law of sines? Well, because when we know two angles, we know the third angle really easily. So we will always have a side in its opposite angle, no matter what. So let's say this angle here is 88 degrees. This one here is 51 degrees. And this side over here is given to be 14 feet. And let me label this. So how do I find my missing pieces here? First of all, do I have a side in its opposite angle? Well, the only side I have is 14. Do I have its opposite angle? No, but we can figure it out. Very well said. What's it going to be? Well, 180 minus 88 and minus 51 is 41 degrees. So now we have all three angles. Now if we have a side at all, which we do, we must have a side in its opposite angle. That's going to be the 14 feet is going to be over the sine of what? 41 degrees is its opposite angle. Let's say we want to find side A. What's that going to go over? Sine of 51. What do we know about A compared to 14? This better be bigger. So let's cross multiply and divide here. 14 times sine of 51 divided by the sine of 41. 16.58. So that's 16.58 feet for A. What's that? Well, they're different. I just put them on there to mark that as an angle. There. So anyway, to find C, I'm going to use the same type of setup, the exact same setup. 14 over the sine of 41, 41 degrees, equals C over sine of 88 degrees. Now we expect C to be larger than both of those. So we'll cross multiply and divide, and hopefully it's bigger than either of them. 14 times sine of 88 divided by sine of 41. 22.33 it comes out to be. And yes, it is bigger than either one of those. Questions? What's that? How come this is 41 degrees? Because this is the side I was given, and that's the angle across from it. So let's look at another example. First step, do I have a side and its opposite angle? Always the first thing I look for. No. So we're going to have to find angle C here, which is going to be what? 47 degrees. So 47 degrees there. Now what do we do next? Okay, yes. The side that we have is the 28. Its opposite angle is 47. So 28 over the sine of 47 degrees. If I want to find side A first, what goes on the other side? (101), right? So we'll cross multiply and divide. 28 times sine. Where are you? Sine 101 divided by sine 47. That can't be right. Let me try that again. 28 times sine 101. 37.58. So 37.58 feet for A. Now that makes sense. 101 is the biggest angle in this triangle. Now to find B, we're still using the 28 over the sine of 47, because that is our side and opposite angle that we have. B over the sine of 32. Now 32 is the smallest angle, so B better be the smallest side. So 28 times sine 32 divided by sine of 47. So 28 times sine of 32 divided by sine of 47. 20.29. And yes, that is smaller than the 28, so that does all make sense. So in this triangle, again, there's no right angle, so the first thing we look for is there a side and its opposite angle? Yes, there is. We have 27 over the sine of 65 degrees. So now we can find What? Well, what's the only other piece of information we have?
Side B.
23, side B. So that means we're going to be looking over here over the sine of angle B. So I'm going to cross multiply and divide this way this time. So that's going to be sine of 65 times 23 divided by 27, which will give us 0.7720. Is that our angle? No, that's the sine of the angle. This is sine of B here. So I have to do an inverse sine. B is going to equal to the inverse sine of 0.7723. So now in our calculator, to avoid a huge round-off error, here's how we're going to do this. You're going to do second sine, and then rather than writing that down and typing it back in, you're going to do second answer. That's telling the calculator to use the previous answer in the inverse sign, giving us 50.54 degrees. Some of them will do it that way. Okay. So we got that angle. Once we have that angle, now we have two of the angles. We can find the third one here by doing what? Well, 180 minus the 50.54 minus the 65, giving us, well, that sucks. Helps if I put minus instead of times. 64.46 degrees. Everybody see where I get the 64.46? Just adding up the angles and taking it from 180. So now we've still got our 27 over the sine of 65 degrees. Now some might ask, why don't I do 23 over the sine of 50.54 degrees? I could. Should work out the same. The reason I go back to the 27 and the 65 is that's information that was given to me. Assuming that whoever gave me the information is giving me the correct information, I know that's right. The 50.54, I could do 23 over 50.54, but I calculated the 50.54. There is a small chance that's wrong. So I always want to try to go back to an original, what they call given information, as much as possible. So now this is going to be side C over the sine of 64.46 degrees. So we'll cross multiply and divide. 27 times sine 64.46 divided by sine of 65. 26.88 for C. Does that make sense? Yeah, it's in between those two, so the size should be in between those two as well. The 64 degrees is a little bit smaller than 65 degrees, so it should be a little bit smaller than 27 feet. Questions? In your notes, find the missing parts of this triangle. Big ones are always angles, little ones are always... So, we've got B, 27 feet over angle B, so sine of 62 degrees. The only other piece of information we're given is angle A, which is 49 degrees, so it's going to be little a over the sine of 49. Cross multiply 27 times sine of 49 divided by sine of 62. 23.08. So A is 23.08 feet. C, of course, is 69 degrees. So side C, whatever, 27 over the sine of 62 degrees again, equals side C over the sine of 69 degrees. So cross multiply and divide, 27 times the sine of 69 divided by the sine of 62. 28.55. How many of you had all that? Perfect. Let me give you another one. What's that? Give this one a shot. This one's a little bit different. In this one, we are given two sides and one angle. When we're given two sides and one angle, we have to be careful. Most of you will have found an answer, but it's not the only possible answer. Because if I draw this out, so my triangle looks like this, A, B, C, where A here is 29 degrees, side A over here is 14 feet, and side here is 27 feet. Is that the only triangle that could be found using this? Say no. No. Side A could have gone like this as well, and side C here could be an obtuse angle. Or angle C could be an obtuse angle, I should say. It could form that triangle. We don't know whether side C is acute or obtuse here. When we have two sides and one angle, we look at our pair that we have. Remember, we always have the pair, one side and its opposite angle, right? If the side that's opposite the angle is shorter than the second side, we have a problem. Because it's possible for that third angle to be obtuse. So we need to be told whether C is acute or obtuse. So let's take this same information. I'm going to give it to you in picture form. So A is 29 degrees, little a is 14 feet, and little c is 27 feet. Now see if you can find the rest of that triangle. I am telling you from this picture that angle C here is definitely obtuse. Well, we have 14 over the sine of 29 degrees equals 27 over the sine of C. I'm going to cross multiply and divide sine of 29 times 27 divided by 14. 0.93498, so 0.9350 equals the sine of C. So C is the inverse sine of 0.9350. So I do second sine, second answer, 69.23 degrees. But wait a second, C is obtuse. Is 69 obtuse? No, it's not. But recall, a unit circle. We have a sine here of 0.9350 on that angle. There's also an angle over here that has the same sign. And those two angles are supplements. So we have to do the supplement of 69 degrees, which is going to be 110 degrees. 110.77 degrees. So angle C is 110.77. Now we can find B up here, which is going to be 40.23 degrees. We just subtract them from 180. Now you can find side B. Make sense? Find the missing pieces of that triangle. What'd you find here? Okay, let's set it up. We got 38 over the sine of 24 degrees equals 75 over the sine of B. So sine 24 times 75 divided by 38. 0.8028. And I'm not going to write out the inverse sine. We're just going to go ahead and do the inverse sine. Second sine, second answer. 53.40. But of course, we got to subtract that from 180. It's 126.60. Is that what you got? So that means this one over here is 29.40 degrees. Is that correct? What'd you get for C? $45.88 feet. Or 86, sorry. I don't know how I got it from 85 to 88. 0.86 feet. Sound right? Okay. When you come back from break, I want you to work on this problem right here. I'm going to put up. Actually, you know what? Nah, you don't need a picture. You guys, big boys now, you can do it without. We're going to work on that problem when you get back from break. Go take a break. We'll be back in here at 1:33.